Hello, my differential equation class. Today we go to a little bit back and go backwards chapter 3 and cover section 3.2 and continue. Today is 3.1. 3.1, 3.2, 3.3. But today is 3.1 because I want you remember what is mean power series. And first theorem. And how we can use this power series for solving differential equation. First theorem. I think all you remember power series is fx equal, let's go something very simple, n equal from 0 to infinity. 0 to I think I need clear and then write little bit lower than you can see. Okay, one more time. Theorem. Let's go. Our function fx is power series, where it says n from 0 to infinity, c n x to the power n. Then this is all theorem you remember what you study in the Calc 2 class. Then derivative this function f prime x, it will be power series and start with 1 to infinity cn times n, but power x is n minus 1 last. Second theorem, this is theorem 1. Second theorem 2, tell us if you have two power series a n x to the power n and from 0 to infinity and series b n x to the n equal some different power series for any x, this means our coefficient is equal. And third theorem, about radius convergence. If you have power series cn x to the n and rho is limit absolute value cn over cn plus 1 and approach the infinity, then it's possible one of these three situations. A, if your limit equal 0, this means rho equals 0, it means series diverges for any x non-equal 0. B, if your r some number greater than 0 and less than infinity, this means some final number, then series converges for any x such as absolute value x less than rho. And last one possible situation, if rho equal infinity, this means series converges for any x. In the book, you have series for some simple function, for exponential function, for logarithmic function, sine, cosine, tangent. Please write for your cheating list these formulas, or try remember some of them. Okay. Doing some example. If I have x squared y prime equal y minus x minus 1. Here I need solving. Okay, pretend y equal series Sn x to the power n, and from 0 to infinity. And then you remember derivative will be series n start with 1 to infinity Cn n x to the n minus 1. Plugging these two series in our equation, we have, if you multiply derivative for x squared, you have series start with 1 to infinity Cn xn, but power x, not n minus 1 anymore, is plus 2. This means n plus 1. Great. Then we have equal our series Cn xn, whereas n start with 0 to infinity, minus x and minus 1. Great. But now we need, just a moment, guys. I write something worse here. It will be n. Okay. We need, for working with series, we need our series start with same number, our counting. Okay, how we can do it? First one, if n equal 1, my power will be 1 plus 1, it will be 2. If n equal 2, my power, we talk about series for left part our equation. My power will be 3 and continue. This means here I can rewrite this series like x to the power n. And start with 2, because for n equal 1 it will be 2. Continue. But what happened here? If n plus 1, I'm substitute with n. This means n, I need substitute with n minus 1. Because it's, looking here, this coefficient is 1 less than this power. This coefficient and 1 less than this power. Okay. What about index, our coefficient Cn? It's same like you have coefficient. This means Cn minus 1. This is a very important part. Please remember, please try understood. Okay. Now, my power starts with n equal 2. This means I need in the, my series starts with n equal 2. This means right part, I write with series n equal to infinity. Here is Cn x to the n. But what does mean? I'm take it C0 plus C1x, and then I have minus x minus 1. Okay. What we have here? First one, we have C0 equal 1. And C1 same equal 1. And then we have n minus 1 times Cn minus 1 equal Cn. Use this fact, what we have. This means C second, it will be 2 minus 1 is 1 times C to the first. It will be 1. The c third. It will be 3 minus 1 is 2 times c to the second. It will be 2. Okay, great. C to the fourth, it will be 4 minus 3. 4 minus 1, it will be 3 times c to the third. It's 3 times 2. I'm especially not counting because you can see now what kind of situation you have, because if we're counting, we cannot see some how it's work. Okay, C5, it will be 5 minus 1 is 4, c to the fourth, or 4 times 3 times 2. We can write times 1. And looking here, whereas 2 times 1, it will be 2 factorial. 3 times 2 times 1, it will be 3 factorial. 4 times 3 times 2 times 1, it will be 4 factorial. And what we have? We have c to the n. It will be n minus 1 factorial. This means our series, it will be 1 plus x plus series when we have our solution when we're solving. It will be n minus 1 factorial x to the power n. Great, but question, this series is converges or diverges? Checking integral convergence. This means we have rho, it will be a limit n minus 1 factorial divided by n factorial. And approach to infinity. I don't write absolute value because factorial is positive here. It will be a limit 1 over n, but this is 0 if n approach to infinity. This means this differential equation has only trivial solution because this is converged. This series is convergence only for x equal 0. Okay. Great. Doing some more example. See some example 2. Example 2. When we have second derivative plus y equals 0. Okay, y is power series and start with 0 to infinity. First derivative, how you remember, it will be cn n x to the n minus 1, and n start with 1 to infinity. And second derivative will be cn n minus 1 x power n minus 2, and n start with 2 to infinity. Okay. Use this fact and plug in our equation. We have sum n start with 2 to infinity cn n minus 1 x to the n minus 2 plus cn x to the power n equals 0, and start 0 to infinity. Now we rewrite our first series. This means we need to rewrite this way, which is power will be exactly n. What happened if it's n equal to? Your power is 0. Okay. Your n from 0 to infinity. Here we write x to the n. But what you know about coefficient? Coefficient c have index 2 more than power. Okay, great. This means here we have cn plus 2. This is 2 more than power, n plus 2. Okay, I need more space, sorry. No, this one. 1 less than power, it will be n one more. This means n plus 1, or 1 less than you have here, and x to the power n, and start with 0, plus cn x to the power n, and from 0 to infinity equals 0. Okay, you can rewrite like one series, and we have x to the power n, and from 0 to infinity. Here you have cn plus 2 times n plus 2, n plus 1, plus cn need be equal 0. Because this is need be equal 0 for any x, this means coefficient is equal 0. Okay, what we have n plus 2 times n plus 1, c index n plus 2 equal negative cn. It's mean cn plus 2, we have minus cn over n plus 2, n plus 1. Great. But how it's work now? Looking here. If you have some coefficient, you can use this coefficient and found coefficient after 2. This means if you have C0 here, you can found C2. If you have C2, you have C4, and continue. This means looks like we have separately for even index and for odd index. Okay, doing something. This means C second one, it will be minus C0 over n equals 0. This means denominator will be 2. If you try found C4s, you have c to the second, negative c to the second, and then you need 2 plus 2, it will be 4, times 2 plus 1, this will be 3. But we remember how we can found C2 use C0. This means here you have C0 over 4 times 3 times 2. Looks like we one more time have factorial here. This looks like C0 for 4 factorial. Here we can plug in minus C0 for 2 factorial if you want. Okay, it's work. Continue check. C6, it will be minus C4 over 4 plus 2 is 6. 4 plus 1 is 5. But this will be C0 minus 6 times 5 times 4 factorial. It will be exactly 6 factorial minus C0 over 6 factorial. And every time we have negative, positive, negative, and if you're checking, it will be continuous. This means you have one of your series, it will be some part of all depends C0, some coefficient. Okay, let's go. We found odd coefficient C3, it will be minus C1 divided by coefficient is 1, this means 1 plus 2. Index is 1, this means 1 plus 2 is 3. 1 plus 1 is 2, this means here we have 3 times 2, it will be minus C1 over 3 factorial. Okay, C5, what this will be? Minus C3, 3 plus 2 is 5, 3 plus 1 is 4, or plug in C1, you have C1, 5 times 4 times 3 factorial, it will be C1 over 5 factorial. Looking how interesting we have. We can rewrite our series like, our answer like C0 when you have 1 minus x squared over 2 factorial plus x fourth over 4 factorial minus x6 over 6 factorial and continue, and plus some c1 where you have x minus x cubed over 3 factorial plus x fifths over 5 factorial minus x7 power over 7 factorial and continue. Looks like your solution is separate for two series. This means you have two linear independent functions for your answer. Okay. Doing one more example. What happened if you have some initial point? This is question number 20 from your book. Okay. 20. You have second derivative minus fourth y equals 0. Y from 0 is 2. Y prime from 0 is 0. Okay, y is same how we did before, cn x to the n, and from 0 to infinity. First and second, no, I write what is second we used before. It will be cn n minus 1 x to the n minus 2, and start with 2 to infinity, and plug your equation. We have series and start with 2 to infinity, cn n minus 1 x to the n minus 2 minus 4 times, maybe 4 I go to inside series, this will be more clear. 4 cn x to the n and start with 0 to infinity equal 0. And now we rewrite our function how we did before. We have series and start with 0 to infinity, cn plus 2 n plus 2 n plus 1 x to the n, 4cn x to the n, 0 infinity equals 0. And this means you have cn plus 2 equal 4cn, cn plus 2 equal 4cn over n plus 2 times n plus 1. And what is interesting we have here? If we try write all even, c second will be 4c0 over 2 factorial. C fourth will be 4 square c0 over 4 factorial and continue. How we did before? C3 equal 4c1 over 3 factorial. But remember, we have initial point. How you remember, how you can go to back in the series, you can easily see y from 0, it's exactly, it's equal c0, and derivative c from 0, who is equal 0, it will be first coefficient, c1. This means, use this fact, we have all odd coefficient is 0. This means we have even coefficient c. 2k will be 4 to the k theta 0 over 2k factorial. If you use this fact, you have then plugging 2 and you have finally you have 2 to the 2k plus 1 over 2k factorial. Looking at some radius convergence, what we have here, we have, it will be limit k approach to infinity 2 to the 2k plus 1 over 2k factorial divided by, this means multiplied by flipping fraction, 2k plus 1 factorial divided by 2 to the twice k plus 1 plus 1. You can easily see, or we continue. Okay, it will be it will be 1/2. Here we have 2k plus 1 times 2k plus 2. If k approach to infinity, you have infinity. This means our series is converges for any x, and our series, our answer will be series k start with 0 to infinity 2 to the power 2k plus 1 over 2k x to the power 2k. See, we solving our problem. Okay. If you have any question, please write me, give me now.